Yeah, thank you for the kind introduction. We've already heard a few talks today and many conversations yesterday and in the past 2 years, basically, talking about Gen AI, what it can do, what it should be able to do, what it can't do. But I think the stage is called applied stage, so maybe we should just apply it and see how it works in the actual production environment. So from this point of view, we at SVA already implement GenAI at our clients. And I want to give you a little overview how we are doing this at the moment from a concept point of view, but also on the execution part. So I will detail a use case rather technically, but I hope you can take something from it. So first of all, I already had this nice introduction. Actually, my colleague Stefan Kammer was supposed to give the talk, but sadly got sick on short notice. So I wish him a speedy recovery if he's watching. But I've been working with machine learning for 2 years now at SVA and also starting GenAI related topics. But that's enough from me. Now, actually, we're going to start with the use case itself. When we're working with the clients, we mainly see the same pain points popping up everywhere on a daily basis, where you have the use case of actually where you need to retrieve data, knowledge, which is somewhere hidden in the organization, in the corporation, or you need to access data for a production facility, for example, and then in the end, you also need to present it to your stakeholders. So the typical workflow, as you can see here, is for that an employee gets a task where he usually needs to figure out what he needs to do specifically, who he needs to talk to. He needs to gather data, which is mostly distributed throughout the firm, and then analyze it, see what insights he can get, visualize it, and then present it to the stakeholders who need to be able to do the right decisions based on these metrics which are presenting. And as you can see, there are many tools people can use. So the tool landscape is way too broad by now. It's actually growing even faster day by day, which means nobody really can handle these tools on an expert level, which makes it necessary that you have which makes it necessary to consolidate everything under one hood or even automate it if possible. So that you do the burden of knowledge, so that you reduce the burden of knowledge from the employees and automate it if possible. And this is where we come in with our GenAI approach. In that case, the idea is, this is now the high-level overview, that we have a query. Example, I need to report on our production facilities, and now we want to get the actual answer to this question. And what we are employing is an agent framework. This means we have one or more agents, large language models, which basically translate the incoming query into a useful thought, train of thought, which then is able to be executed. And this means, rather concrete, that the agent is figuring out, okay, what does our client actually want to do? And then accessing data sources if needed, different databases, SQL, vector database, or in our specific use case, Signavio, which is a process management product. To be able to do this, we employ different LLMs, depending on the actual use case. And combining this with the agent framework enables the architecture basically to answer the question which the client has been giving to it. Now I want to zoom in into the heart of this architecture, which is a single agent. So just remember, you can have more than one agent, but one agent itself can cover a specific domain, a specific topic, let's say the retrieval of the processes which are in the organization. So you have different functions which have to be defined, And the agent now maps basically the query onto these functions so that you can then execute the functions, get the answer. And because it's a self-referential large language model, this means it feeds itself in a kind of a feedback loop, the answer into itself until it's happy enough or until the answer is good enough for what's actually needed. And this allows to have an agent as kind of like the first stepping point in order to actually get the answer you want to. But you don't need to only you don't need to use only one agent. You can use multiple agents. That's what I meant. That's because you can think of an agent as a specialist for a specific domain. Usually you don't have one expert for everything. You have experts for rather narrow fields. That's exactly the same idea here. Because what you can do now is you can combine multiple agents for different domains. And depending on the query, one or even more agents are basically triggered. They figure out what needs to be done and then accessing the tools which are needed for this. So you have, from an architecture point of view, you have the agent framework consisting of different agents which are responsible for different topics and domains in the end. For this, you need a rather good conversational large language model like Llama 3, for example, to be able to handle the conversation with the client. But you need more than one LLM, as I said in the beginning, because in our eyes, it's really good that you don't use one big LLM all the time. Sure, you can throw ChatGPT with all its powers onto the problem, but it's most of the time it's overkill if it's even able to do the task which you want him to do. So for this, we use different LLMs, and specifically for our clients, we are using watsonx from IBM, because there we have a platform where we can select the different LLMs, swap them out, swap them in as we desire. And these foundation models then are tailored towards specific tasks. So this is the main difference. You have foundation models which are good in one thing and maybe bad in another thing, but then you simply use another large language model. That's exactly the point. And smaller models are more effective cost-wise, but also energy-wise. So this is really the selling point in this, especially also for smaller organizations, which really don't need a whole package, but rather specific foundation models. So this is really good. Also, IBM, by the way, provides some nice models, the Granite series, where they know exactly, these are IBM-made models where they know on what data the models have been trained. So from the governance point of view, this is really a step ahead compared to many of the open source or even the third-party models. Now, in order to access this kind of model catalog, you need to use watsonx AI, which we are using at a client. So on the one hand, you can train, validate, tune, and deploy these AI models rather easily. You can swap them in. If you have a new model which is better than the old one, you can just replace it, for example. But there's also a nice no-code or low-code environment, the so-called prompt lab, which I find really intriguing when you actually need to work with it, because you don't need to have much knowledge to actually prompt tune a large language model. It's rather easy. It's an iterative process where you can come to a good result rather easily. You can just change the hyperparameters, basically, so like the tuning parameters, how greedy the model is. You can change the maximum amount of tokens it has, stub sequences, and similar things. So this is really good way to go from the testing stage to the productive stage in the end. Also, all of these LLMs are accessible via a REST API. This means you can easily integrate them into your existing ecosystem. You don't have to use, you don't have to add a completely new kind of software, but you can simply use the functionality of calling these large language models via the REST call. Additionally, so this is watsonx.ai. Additionally, there's also watsonx.governance, which covers the ML lifecycle of your large language models. So it has a model registry where you can have a nice overview of what models you have deployed. We know of clients who have, I don't know, like 50 and upwards models in usage, but nobody really knows what's going on in each specific one because there's no overview. So this is an important step. But you can also get metrics about fairness, bias, how the model behaves during its deployment, but you also know the model lineage. So you can follow the model, how it has been changed, how it has, on what data it has been trained specifically. And this is an important step in order to comply to the EU AI Act, for example. So this is really an important step regarding this. So with the building zones set up this way, now we are coming actually to the execution part I promised before. The idea here is the client should be able to have a conversation. I mean, this is nothing new, but it's a really convenient way for humans to interact with any kind of system. Simply use natural language for it. So what we envision basically is that we have this kind of conversation. At the top is the question or the input from the human. At the bottom is the response from our framework. So for example, somebody needs to report on production facilities, and then we will receive the process. Also where this step the client is specifically in the process chain. So usually you have many processes chained together, and there you can then know where you are specifically in this kind of chain. And furthermore, after you know what process you are at, you can tell the LLMs to gather the relevant information in a nice compact way so that you can actually use it for your own or present it right away. This is good to represent the data via dashboards, for example, but you can use anything you like, and then you can go even a step further and then ask for a summary about these kind of dashboardings you do. So you can really be flexible with these kind of LLMs, obviously. So this is the main idea. This is basically what the client is seeing on the surface. How does it look in the background, on the technical side of things? For this, we have to do a kind of a pre-processing step. So in this use case, if you want to see the processes which are available in the organization, we first have to make them available to the LLMs. So this means you have your data, in our case, Signavio data, which comes in, is converted into a graph, and then passed into a JSON, which is a file format, which then again can be converted into text via an LLM. And at that point, you have the processes basically as embeddings available, which means you can use these embeddings you can store these embeddings in a vector database, in our case, for example, Elasticsearch, and therefore feed them into your large language model. So this makes your processes available within this kind of context. This is a self-built pre-processing pipeline from us, which is necessary to be able to do the next steps. because once this pre-processing pipeline is set up, we can then actually do the productive stuff, which means we have our query, which then gets fed into our multi-agent framework, where you have many agents kind of arguing and discussing who needs to do what exactly, depending on the query. And then once they decide, okay, what needs to be done, in this case, it's the process agent, you go to you call the actual functions, the green ones, and these are act out, or these are enforced then by the agent. So you access the vector database in that case, and you can access the processes that way, and then you can get back the relevant process data and return it to the customer, basically. Depending on the task, we are using different large language models, as I said in the beginning. For the multi-agent framework, we are mainly using Llama 3 by now. And for the process retrieval, we use GenAI from IBM. And here you already can see, yes, the use case I'm presenting is rather specific. It's focused on the processes, but in the end, it doesn't matter what kind of agent you are using. I mean, you need to set it up for your specific use case, but implementing another agent once this pipeline is up and running is really not that difficult, which means you can expand on this kind of architecture rather easily once it's up and running. So then the step afterwards, after retrieving where you are in the process step or in the process chain, is to generate dashboards, graphs, showing the KPIs you want to know. So this is basically the same for a different use case now. So prepare the relevant information is the query, which means based on the results we already had, finding the right processes, we now employ different agents. The first one is getting the right KPI, so it's accessing our database in the top right to find the right KPIs, use them, store them, calculate them, and these are then used in another agent, the code generation agent, which is using StarCoder, for example. It's an LLM focusing on code generation. And that agent generates then Python code, in our case, for visualizing. So then you have a nice chain coming from the first query from the customer, where he wants to know, okay, what do I need to do, where I am in the process structure, to, okay, now I know what to do, but please give me just a summarization of everything I need to know and present it nicely. So this really speeds up the process in the end. So with that, I come to the conclusion and also the outlook at that part. Working with our clients, we are seeing a huge interest in combining this GenAI approach, because this is scalable from small organizations to big ones. It doesn't matter, and as I said, the biggest selling point is that it's really flexible. So once the baseline is set up, once you have established one use case, then you can go and add even more rather easily. And employing Watson-X AI, we also can swap out the large language models also rather easily in the future when there are better ones, or simply if the governance on compliance side, the laws are changing, then you can adapt rather easily and fast. The use case was focused on process retrievement, basically, but I mean, it's not really a surprise that you can change the topic completely and you go to human resources or customer support, where studies found that you can increase the productivity or the efficiency up to 80%, depending on the specific use case, obviously. So this enforces the idea that we are going from people doing all the work to people asking a business AI agent or employing an AI agent in order to speeden up the whole processes within an organization. And with that, I'd like to conclude my talk. Thank you for your attention, and I'm open for questions.